All right. Well, thanks for coming. I don't think I've ever seen Atlanta so cold as it was today. I was like, am I in the right place? But it's great to be here. And I want to talk about type inference, friend or foe. I want to talk about type inference mainly because type inference has been around in Java for a long time. And yet, developers are very surprised about type inference when it comes to what we have available in Java 10. So I want to talk a little bit about type inference as it's been, and then, of course, what's available in Java 10, and also maybe look at when to use it, when not to use it. Like everything else, there are times when it makes really good sense to use. There are times when it doesn't really make any sense to use. So we'll talk about the pros and cons of it. Best time to ask questions or make comments is when you have it. So please don't wait till the end. Anytime is a great time for questions, comments, anything you want to talk about. But let's talk about typing really quickly. Well, we often talk about Java being a statically typed language, but I want to step back and think about typing in general just a little bit. So if you really think about typing, we should really look at it from not just static versus dynamic, but it turns out that we can actually look at it from the four quadrants of it. So at the very top, of course, is static typing. The screen is not showing up the entire thing here, but that's a static typing. And then, of course, you have the dynamic typing right at the bottom. So we often talk about static type languages versus dynamic type languages. But unfortunately, that's not enough because we also have to think about what I would like to call as a strong typing versus a weak typing. And so what's the real difference between these? We know what static and dynamic is. Static is when your compiler, if you have a compiler that is, enforces the type at compile time. What if it's a language that doesn't have a compiler? So I normally say you have a type sanity at code writing time. So before the program actually executes, you can verify what the type information is. Dynamic typing, on the other hand, is where the language is pretty lax about type information. You don't have to really enforce it when you write the code. So the vertical is more like what happens when you write the code. The horizontal is what happens when the code actually is executed. So in a language where the type verification happens during runtime versus there is really no type verification at runtime at all. So from that point of view, if you think about Java for a minute, we know that Java is statically typed, but it also turns out that Java is also strongly typed because it's not very uncommon to get a class cast exception, if you will, for example, or you're trying to really do something with a type that's not really valid at runtime, you'll get an exception during runtime. On the other hand, if you think about languages like C++, we know that C++ is a static type language, but it turns out that C++ is statically typed, but it's actually weakly typed. And the reason is once you compile your C++ code, there's all bets are off. Whatever happens at runtime happens. The proof for it is you go to any programmer who's a C++ programmer, and you'll notice they're always eager to go to work because they have no clue what the code is going to do, and they want to go find out. And that's because it's statically typed versus weakly typed. And whatever comes out of that V table at runtime, God knows it's going to do that. On the other hand, if you think about languages like Ruby, we know that Ruby is dynamically typed, but it turns out that Ruby is actually strongly typed as well. So, if you have used Ruby, you would get a runtime exception if you mess with the wrong type at runtime. So even though you don't enforce the type at code writing time, there is a type sanity available during runtime. It protects you. On the other hand, the best language ever humans have created, you know what I'm talking about? JavaScript, right? And when you execute JavaScript code, what happens? JavaScript is, as we know, dynamically typed. However, when you execute the code, it is actually weakly typed. It's garbage in, garbage out. There's no way to predict what JavaScript will ever do. And in fact, somebody tweeted the other day, I thought that was a brilliant tweet. I don't remember who said this, but the person said JavaScript is weakly typed because every week I wonder what the code is doing. So it's a weak type language, but it's also dynamically typed as well. So there's a spectrum here of languages, and you can take your own favorite language and you can map it on these four quadrants. And you may decide to push it a little up or a little left or a little right, depending on how you feel about its typing nature. And that's a nice fun part of it, is that not all languages are really dynamic versus static. There's a lot more to this if you really think about it. So from that point of view, we know that Java is statically typed, But on the other hand, of course, Java is also strongly typed. But what does it really mean to be working with a statically typed language? Now, to be honest about this, I started programming in language like C++. That's where I spent a lot of my time. And then, of course, I went on to program in language like Java, language like C#. So for a lot of time in my programming life, I spent time on static type languages. Little did I know that I didn't really know what static typing is, because these languages had a very limited view of what static typing is. And I had a really big surprise when I started programming in Haskell. And then I realized that saying Java is statically typed and saying Haskell is statically typed is a disgrace, because those are in a completely different spectrum if you really think about it. And then it turns out that static typing doesn't mean you have to type the type information with your fingers all the time. So the compiler can be really smart to figure out what the type is. And unfortunately, a lot of static type languages we've been using force us to type the type information. And there's a really good number of languages which doesn't require you to really type that. In fact, this was a surprise to me because I failed learning Haskell 2 times. And everybody kept saying Haskell was cool, and I really had a really hard time learning Haskell. And then the 3rd time I picked up Haskell and said, no, I really want to learn it. And that's when I realized that what was making it really hard for me to learn Haskell was all this noise about putting all the type information. So the 3rd time around, I completely quit putting the type information in Haskell, started writing code without types, and I let the compiler do its work. I almost heard the compiler say, finally understand what I'm about, right? So the point really is you don't have to really work that hard to put all the type information, because the compiler is smart enough to really infer the type information in a language like Haskell, and you don't have to really work that hard in reality. So given that, of course, let's talk a little bit about, what does it really mean to use type inference? So we talked a little bit about the spectrum of these languages. We talked about static type languages, but there's a lot of static type languages that have a very healthy dose of type inference. One of them, of course, if you want to think about it, is really a language like Haskell. Just to entertain this thought for just about how that feels to really do this, let's take a look at an example of this, if you will. So in here, I want to let's go to the command prompt just for fun's sake. So let's go ahead and bring up the Haskell REPL right here. So in this case, I want to write a function. So let's say add, let's say A and B is equal to A plus B. Now, if you really think about this, there's not a whole lot in here other than saying, A plus B is the result of this function add. But what about type? You could sit there and specify what the type of A is, what the type of B is. Nothing wrong in doing it if you really want to, but you don't have to really spend that effort doing it. So if I said 1 and 2 over here, you got back the result 3. But what if I said 1 and let's say, hi and there, for example, and notice I got an error. But look at the error we got. It says no instance for num arising from the use of. So it kind of infers what the type information here is. In fact, let's try this one more time. I'm going to ask it to specify the type information, if you will, and then ask it to really, provide the details about, I'm messing up here. So I want to really ask it to give me the type information. So let's go ahead and try this again. So let's go ahead and say, call the let add. And of course, if I were to, ask for the add itself, you can see that it's actually a number. So how did, the language know? This is a little bit, intense, if you will. I'm not a big fan of going this deep, but what the language actually did is it digged into the implementation. And it said, gosh, you're using a plus. What in the world has a plus? And so it figures out that it's got to be a number based on the operation of plus. I know that's a little, maybe taking it to an extreme, but it relies on the implementation to figure out what the type is. Now, the point really is the language can actually figure out what the type is, and there are other languages that do this quite extensively as well. So here's an example, for instance, in Kotlin. So I'm going to say, let's call it as greet, and I'm going to say that this is a string, and I'm going to say this is a hello, and I want to go ahead and print out the greet and display whatever the value of greet here is. And as you can see that it's hello. But in this case, it's pretty darn obvious what the type of greet is because you specified that it's actually hello. So you can actually drop that colon string, and the code, as you can see, is still working. you don't have to really say what the type is. But make no mistake, the type is extremely clear and there's no ambiguity at all. It knows at compile time. So for example, if I were to go ahead and say greet is equal to, let's say, a value of 1, you will notice the error that it gives us is the integer literal does not conform to the expression of type string. So you're not allowed to put a number where a string is expected because it found out what the type is on line number 1 based on the context. So in other words, a language can be statically typed and use type inference because that information is available at compile time. So in this particular example, this code is as good as we specifying the type to be string. We just don't have to waste our time and effort saying it. There are other languages that do this as well. For example, TypeScript. TypeScript is a statically typed language that compiles down to JavaScript, but TypeScript also has a fairly good, healthy dose of type inference, so we don't have to really specify it. But let's talk about Java and see where it takes us in terms of what Java provides for us. So languages that have been moving towards type inference, I should probably add C++ here because C++ also has auto keyword, and auto is really kind of like a var in Java. So languages have been moving in this direction for a while. And of course, C# has had this for a number of years. Java is probably the one that has come to the party pretty late in this regard, but languages that are considered to be statically typed are moving in this direction. But Java itself has been steadily moving towards type inference for quite a long time, actually. This started back in Java 5 with generics. And we know that generics are giving us the ability to write code that can work with multiple types. But what about type information when it comes to generics? And that's been around for quite a long time. So let's take a look at an example of how that actually pans out. So here is an example of using generics. So let's take a little example here and play with it. So I'm going to say list of string. I'll say names is equal to new array list over here of string. And then, of course, in this case, I'm going to provide a names.add. And let's go ahead and say add Joe to it. So that's a fairly simple example. We are adding Joe to this particular object. We can simply display the result. But what if I were to go ahead and say names.add1, and clearly we know that shouldn't be possible, and we get an error saying it's incompatible type. Int cannot be converted to a string. So that's pretty nice. We have a generic type, but we also have information about what the type of the generic is. We cannot put an arbitrary type into it. While this is statically typed, we know that this is pretty noisy in terms of the code. So thankfully, we can reduce some of the noise in here so that we don't have to say string multiple times here when we are writing this code. But when it comes to this, we didn't have to really specify a whole lot of type information beyond this. So we can get used to this pretty nicely over time, so much so that we don't even think about it quite a bit as we move forward. Let's go ahead and take a look at a slightly different example here. Let's take a look at this little piece of code just to see where things could go potentially wrong along the way. I'm going to reduce the font a little bit so we can see a little bit more of this. So let's give it a try here. So right here, what I want to do is I want to use, this is just an arbitrary example. I want to use from the RxJava a flowable.create. So I want to call the create method. And what am I going to send to it? I'm going to have an emitter, and I'm going to pass this to a function called emit, where I'm going to pass the emitter to it. And then I'm going to just fulfill the function needs over here. Now, clearly, I don't have an emit function, so I'm going to implement the emit method. So when I implement the emit method, I want to say this is going to start emitting an integer value, as you can see here. Now, this is going to start emitting integer. The body of the code is not relevant. This is, after all, a void method, so we don't have to worry about it. But notice the compiler is not very happy already. Now, generics is awesome. We can work with this pretty nicely. But occasionally, you will come across code like this that can be really annoying. I worked on a project for a client where this was a fairly complex systems. We had generics from hell. And we had to specify type very much every corner we turn. We got to keep specifying the type information. It was horrible because we would write code in 5 minutes and spend 15 minutes helping the compiler to figure out what the type is. What was even more annoying was we shared the room, we were pair programming, and we shared the room with a Python programmer, a young programmer. And we really hated him because, he would be sitting and writing the code, and then he would take a pause, and we look at the two of us writing Java code and say, oh, still fighting that compiler, are you? And we were like looking at him, like, why don't you shut up and do your work, right? And of course, several months went by, we just took this beating from him. But eventually, it all kind of worked out in the end, because there was one day we heard a really big scream. He banged on the keyboard. He was very angry. We kind of paused and said, what's going on? He said, this program, it ran for 3 hours, and damn it, the last line had an error. We're like, welcome to Java, right? So the point really is, it kind of balances out. You have to deal with it. But in this particular case, if you notice, what is it complaining about? Well, it's trying to tell us that this emitter, if you look at the error, it says that that emit is expecting, is receiving an object of integer. On the other hand, it says you're going to be passing an object of object, a flowable emitter of object. So clearly, the compiler is a little confused here in terms of the type information. So you would probably have to say integer over here, and then kind of tell the compiler, hey, I really want to bind this to an integer type. And notice now the compiler is not unhappy. So you had to really provide a little bit of a type hint, if you will, and say that this is going to be an integer I'm going to pass in. And again, these things can be a little annoying. And imagine this one is a more complex type and you have multiple values to it. This is when you truly begin to appreciate the type inference that kicks in eventually, and you can benefit from that. So you are using the type information already, type inference rather, in Java 5. Well, Java 7 made things a little bit better. So what did we have in Java 7? Well, in Java 7, we did not have to specify the type in both places. So Java 7 introduced the diamond operator. So as a result, you can simply say string names is equal to new array list, and you're able to specify this very easily. And this is a blessing because we don't have to say the type twice. This is even worse if you have to say it twice when that particular angle is going to contain more complex values. So if you have to specify 2 or 3 values in there, that can be really annoying. Like imagine you're specifying a hash map and you want to say the string comma value, which is an integer type, that can become really noisy in the code. So this is really nice. Though there was a limitation in Java 7, we'll come to that in just a minute. But what is the limitation in Java 7? If I was programming in Java 7, unfortunately though, you couldn't have done this. So Java 7 does not have anonymous inner classes with diamond operator. I'm not using Java 7 right now, but if I was using Java 7, this code will not compile. And the reason it won't compile is Java 7 says, if you're using a diamond operator, don't use an anonymous inner class. So if for whatever reason you wanted to use an anonymous inner class, then you have to specify the full type in Java 7. Well, thankfully, that limitation is no longer there. That's been fixed in Java 9, and you can use anonymous inner classes with diamond operators. So that's, again, much better when it comes to a type inference. What about Java 8? So we can see already that there is a bit of type inference that's been quietly happening in Java. But with Java 8, we probably saw this more distinctively, which is with lambdas. And I'm a huge fan of this, honestly. So let's think about this for a minute to see what that really means. Suppose we have a list of integer, let's call it as numbers, is equal to, and let's say list of, and I'm going to create a list of numbers, let's say 1 to 10 over here. So I've got these numbers 1 to 10, and I'm using the Java 9 list of, or you can use arrays as list if you really wanted to. And I can say numbers dot, let's say for each, and what am I going to say here? I can say integer element, and I can then output the element that we have on our hands. So when I run this code, it's going to loop through and print all the values. Well, this is a lambda, as we know, and the lambda is taking a parameter of type integer named e, and then of course it's just printing it out. But if you look at this particular lambda, what is the context in which we are using this? We're using this lambda to iterate over a collection, which is the numbers. Now, in your wildest imagination, think about it. If I give you a collection of numbers and you put your hand into it and pull one element, what would possibly the type of that element be? A dog, right? So it's got to be a number, an integer. It's very clear what the type is. So why bother specifying the type over and over? So in this case, you can use type inference rather than having to really specify the type. So you can rewrite this code in Java 8 by dropping this integer. As you can see, that code works just fine without the information. But as a bonus though, if you were to drop the type information, what you get in return is, if it's a single parameter, you can drop the parenthesis as well. So you don't have to really use the parenthesis and the code still works. Now, of course, a parenthesis is required if you specify the type information. But if you lose the type and if it's on single parameters, you can just leave out the parenthesis, and that reduces the noise in the code quite a bit. So based on the context, you know what the type is. Make no mistake, the compiler clearly knows what the type here is. So for example, if you look at the error, notice the error says location variable e of type integer. So clearly the compiler knows that e is an integer. There is no ambiguity whatsoever. And that is Java 8 type inference. And we make really extensive use of type inference in Java when it comes to lambdas. So you're allowed to put the type if you really wanted to, but you're not required to. Once again, I would argue when this type becomes a little bit more complex, you're really happy that you don't have to specify the type, because that's less noisy for us to write the code. It's definitely less noisy for us to read the code as well, in spite of just not having to type all that. But there are a few limitations of this. One of the limitations, unfortunately, is that you cannot use annotations. So for example, if I were to write this code right in here, I could pretty much say, for example, final, for example, as an example. So if I were to put the word final over there, you can see that the code actually is going to work just fine with the final in the type information. I am unfortunately not able to put the word final here, so I cannot say final here. That's not permitted. Why not? Because you cannot put final alone. You're required to use the type information. Similarly, instead of using final, if I wanted to say not null, for example, well, I cannot use these kinds of annotations either when it comes to type inference. So either you can use type inference or you can use annotations. You cannot have both. And that's a limitation in Java 8. Thankfully, that limitation is no longer there in Java 11, but we'll talk about that a little later. So in this case, there's a benefit to using type inference, but there was a loss as well. You could not use annotations on the parameters if you were using type inference. But once again, as much as I love type inference, it's really important to understand what the compiler is doing. And if we don't, it can be really annoying and confusing at some points. Let's take a look at one example of this. So let's entertain this thought for a minute. Let's say we have a person, we'll call it as people is equal to a new, and we will simply say list of, well, actually in this case, let's say arrays dot, list of. So list of, let's go ahead and say new person. So we'll just say a new person. So we'll give a Joe and maybe a age of this person. And so that could be a little object of a person, a people. Now what I want to do here is I want to say people dot stream, and I'm going to call a sorted method on it. And then I'm going to simply say for each, and let's say system dot out, and we will just print it and println. So I want to implement the sorting on this. Let's go ahead and provide one more here. So we'll say a new person, and we will say Sarah and age 3. I don't want to really sort these two, person, people, object. So what am I going to implement in here for the sorting? So we can say comparing, and we can say person get name, and we could be comparing the people based on the name of the person, if you will. So how's that going to work? Let's go ahead and bring in the comparing. So this is going to be static, and this is going to be comparator, and so this is going to be sorting based on the name of the person. Okay, great. But what if I really wanted to sort based on the age of the person? So we could say sort based on the age, and you can see Sarah is before Joe, obviously because of the age being sorted differently. But on the other hand, look at this for a minute. This is going to be a lambda, so I can say person, and I can say person dot get age. So this is going to be using a type inference. Now, what is the type of a person? Well, we don't say what the type is. To make things really obvious, we'll call this as X to avoid any confusion that type information is available, and it was able to infer the type. Now, how did it really infer the type? Well, very simple. It inferred the type based on the context. So the compiler heavily relies on a context. A compiler will not do magic. Compiler needs things very obvious to it. So what does it do? It takes the comparing. What is the signature of comparing? The signature of comparing is really the following. So the comparing function, it's a static method. So comparing says, I'm going to take a function, and that's going to take a t and a r to perform the comparison. Now, what is t and what is r? Well, r is the return type. Return type is going to be integer in this particular context. But what is the type t? Well, clearly, we don't know what type t is, because if you look over here, there is no information about what the type t is. Well, what's a return type of comparing? The return type of comparing is a comparator of type t. So what the compiler says is, all right, what does the sorted really want? The sorted wants a comparator of type t. But where is the sorted being called? It's being called on a stream of type t. Well, what is the type t for a stream? Oh, that's very clear. It's a person. So it walks the tree and says, comparing is returning a comparator of type t, and that is being sent to the sorted, which is of type t. And I know the sorted is taking a comparator of t, but the t in that context is the stream's type, that's a person. So the compiler had no problem in inferring that because the context information is pretty darn available. Now let's go a little further with this just to see where it's going to take us. I'm going to take this code right here. Let's go ahead and say, just for a minute, person X, and then I'm going to run the code one more time. I gave the type, and then in this case, I'm going to say dot reversed, and I'm going to have it reverse this and sorted. So as you can see in here, it is reversing it. So Joe is on the top, and then of course Sarah comes after that because the age is being reversed. There is no type inference right now because we specified clearly what the type of the person is. But what if I leave out the type of the X over here for a minute? I left out the type and I'm going to compile the code. Whoops, the code doesn't compile anymore. Now, when you run into cases like this, it can be really annoying because why doesn't the code all of a sudden work? It's very easy to deal with it if you understand what the compiler is actually doing. Now, let's go through and see if the compiler has enough information. Well, look at this code right here. You didn't say what the type of X is. So the compiler says, gosh, I don't know what X is. Give me a minute, let me try to figure this out. So it goes to comparing and says, hey, comparing, could you tell me what you are expecting? Oh, I'm expecting a function t comma r. Well, I don't know what t is. Can you tell me a little bit more about t? And the comparing says, all I can tell you is, I am returning a comparator of type t. Okay, fine. Let me see what you're doing with it. A minute ago, that comparator of t was being passed to sorted. But now, that comparator of t is being passed to reversed. What does a reverse to say? The reverse says, if you call me on comparator of t, I'll give you a comparator of t. Well, that's very helpful, thank you, right? So the compiler says, I have gone in a circuit now, and I have no clue what t is. So all I can assume is t is an object. So if you notice the error, look at what the error says. The error says variable x of type object. So the type inference fell flat on its face and said, the least common denominator right here for me is object. I cannot intelligently say what the type is anymore, so that's all I can do. So when you get stuck with problems like this, it's really intimidating in the beginning, but once you understand what's going on, you're like, oh, I get it. The compiler doesn't have enough context. So what can I do to give the context? Couple of things. The first thing you can do here is you can come in and say that this is a type person. And immediately the compiler is like, I'm cool now. You told me what it is. Alternatively, what you can also do is you can say person : get age. And once again, the compiler has enough context about it too. Because again, a method reference has a context of what the class is. So clearly it knows what the type is. But of course, if you want to use type inference in this case, it won't work because it doesn't have enough context. So type inference is awesome, but it's got limitations, right? And some of these limitations are, reasonable because a compiler cannot do magic. It can only work with what it knows. And based on this context, it doesn't really know enough about it. So as a result, it's got to really resort to what it can deal with at the time. So that's one of the things to really think about is what is the context with in these cases. Well, Java 9 has removed one limitation, which is a support for anonymous classes, like I mentioned earlier. So what you can do in Java 9 is, unlike the Java 7 limitation, you can actually do the following. You can say list string names is equal to new array list, and you can end with this, and the names dot add, let's say, Jack over here. But this is Java 7 syntax, but you can also do the following in Java 8 as well, and you can see there's no error for that. So Java 9 removes the restriction. You can have anonymous inner classes with this also. Now, with all that said, let's talk about what Java 10 provides for us. So the point I wanted to make was type inference is not new in Java. And for some reasons, people are somewhat upset when they see type inference in Java 10, and I've heard statements like, my gosh, Java is becoming like JavaScript. And those are really fear, right? It's nothing more than fear. Java is not JavaScript. Nothing can ever compete with JavaScript. So I mentioned the word. You can see what the screen does, as you can see right there. So the point really is that these things are, static typing, type inference is literally, done at compile time. I'm going to disconnect and reconnect and see what it does. So the point really is that Java can really help us to reduce noise in code. That's part of the reason. Let's give it a try. What does it really mean? Well, Java 10 has local variable type inference. Now, that doesn't mean that's going to be the end all. The creators of Java are incrementally introducing this. They're measuring the dose in which we can take as a community, right? They don't want to make this lethal dose so we die, getting this. But eventually, I'm hoping we'll have more type inference than we have today. But let's talk about local type inference really quickly. So here I am going to define a variable. So string greet is equal to, I'm going to say hello. So now that I've created a string called hello, I'm going to go ahead and print out the variable greet. Now clearly, if I said greet is equal to 4, I'll get a compilation error. Incompatible type, int cannot be converted to a string. No surprise over there. But if you look at this code right in here, look at that one line for a minute. What is the type of greet? Well, the type of greet is string. How do we know that the type is a string? One answer is because we said so. But the real answer is because we assigned so, right? So when you look at the right side, we are assigning a string to this particular variable. So it's very obvious what the type really is. So as a result, you can simply say var right in there and you can compile the code. So what does var really mean? Let me put one thing very clear to keep in mind. There is no such thing called a var type. And sometimes developers use this word, oh, it's a var type. There's no var type ever in Java. So what is var? Var simply says, go figure out the type. That's what it really is. So what is the type of greet? the type of greet is string. And so var simply says, I am not going to require the programmer to type in manually the type. You can figure it out, infer it. So var is just an annotation. Var is just a little wink to the compiler, right? You're winking to the compiler saying, hey, compiler, it's very obvious what greet is. You don't want me to say it to you, do you? And the compiler is like, of course you don't, because I'm intelligent, right? So that's exactly what it is. It's a wink at the compiler to say, you know what the type is. You don't want me to be stating the obvious. So in this case, the compiler infers the type. When does it infer the type? Well, it infers the type as if you wrote the type at compile time. So there is no dynamic typing in this case. The var did not reduce the typing any bit. If at all, it probably improved it a little bit, right? So if you specify the type, it's what you specify. If you let the compiler figure it out, it's probably going to do a lot better job than what you and I can do, because it's got more context to infer, and we'll see this a little later on as to how that could be. So in this case, the question is, what's the type of greet? It's very clear what the type of greet is. It's a string. How do we know? So if I go here and say greet.foo, look at the error we are getting. On line number 10, it says variable greet of type string. So it clearly knows what the type of the variable greet is. At compile time, it knows the type is actually a string. Similarly, if I were to assign the value 4, you get exactly the error that you did before. Incompatible type int cannot be converted to a string because the type is inferred as essentially a string. So this is for a local variable. A second thing is that var is not a keyword. Var is simply, in this context, it means that it is for type inference. We'll talk about that a little bit later one more time. So local variable type inference. This is done only where it is 100% clear to the compiler. It's not about you and me. It's about the compiler knowing very clearly what the type is. So what does that mean? So look at this code for a minute. This code actually works, and it knows the type of greet very clearly. Now, if you put a semicolon over here, and then you say greet equals hello. Sorry, timeout. That's not possible. Why not? Because looking at that line, the compiler has no clue what the type of greet is. So this is not a valid syntax. This will not be permitted. So if I try to compile the code, what does it do? It says cannot infer the type of the local variable greet, and it simply says, sorry, you haven't given me enough information to decide what the type is. Now, clearly looking at this, you may say, gosh, why can't it figure out from here? Well, the reason is a lot of things can happen here. You could have a conditional statement. You may assign a number in one branch and a string in another branch, and this can lead to ambiguity and error. The goal is not to make the code confusing. The goal is to reduce the noise without compromising the context and the clarity in the code. So as a result, the compiler says, I cannot really help you here. I will not allow you to deal with the type in this case. So you have to really specify the type. Obviously, I could say string over here for this type over here, and you can see the code actually worked, but that's because you specifically said what the type of greet is. But if you use a var, then it doesn't know. So if you're asking the compiler to infer, it wants to know that very clearly, and there should be no ambiguity whatsoever. So if it cannot determine at that point, it's not going to let you go any forward. This is at the local variable level. So this is only available for local variables. Now, where can this be really useful? A few other contexts where we can benefit from this. So let's give it a try. So I'm going to say list of string, we'll call it as names is equal to. Let's go ahead and say list of, and let's create some names over here. So I want to iterate over these names and print the values. So you can say for string name coming from names, and then you can output the name right in here. And that code worked just fine. Now there's nothing wrong with this, but you can also say var over here, because what's the point in saying it's a string because it's obvious? So why bother really saying it? So you can simply say var over there. So this is for a local variable within the for loop context. So if you don't care to specify the type, that's perfectly fine. Now again, if this were a little bit more of a complex type, you don't have to have the noise of saying that. So as a result, in the for, you can simply leave out the type information and the compiler can infer the type for you, and that's as good as you putting the type in its place, so you can start using that quite effectively. Similarly, you could also use this in the try as well. So for example, if you're writing a try and a catch, let's give it a try for a minute. Suppose I wanted to call a function, so let's call this as public static, let's say void foo, let's say throws a runtime exception. So, so in this case, let's say it throws an exception of some sort, doesn't matter what it really is. So I want to call this particular method. So what am I going to do here? I can say try and I call the foo method. I can say catch. Well, what am I going to say here? Exception over here. And this could be a specific type of exception. I could specify that. Alternately, what if I say var over here to say what the type is? Well, var is not allowed within here. You cannot really put a var for the catch. But on the other hand, what about if I were to have a resource? You know, the try with the resources you could use. So in this case, of course, I'm going to say, let's say sample is equal to new sample to create an object of it. Imagine this is implements auto-closable. So we can say implements auto-closable. And of course, public void close. Now what's going to happen? Well, in this example, of course, the try is using a sample. Let's get rid of this guy here for a second. So you can see, what if I say a var instead of a sample over here? Let's just see if it's actually working. So I'm going to say OK. So with the sample, I can pass the sample to the try with resource. A var for the try with resource, that's perfectly fine as well. So you have to, you don't have to say what the type is. It can infer the type. Again, based on the context, you can use that. Well, yes, please.
How come you have to put a var there if it can tell, because you're in a new scope, that that's a new variable?
Yes, the scope of the sample is within the try block.
Right, so why do you have to say var there? Do you know why they require var there instead of just defining?
Yeah, because you're defining the variable. You're not using a variable that exists already.
So it's back to, you still have to have a declaration as opposed to just the first use.
Yeah, yeah, because the first use is defining the scope as well. Because the scope of variable is when the birth of a variable. You're not accidentally using a pre-existing variable, it's a new variable. Yeah. Yeah, you're still saying that you're defining variable, it's just that you're not specifying the type at that point. Yeah. So, not for fields. Some languages allow you to use type inference for fields. Scala is one example. Java doesn't allow that yet. So in the case of Java, suppose you are writing a field within this class. So let's get rid of all of these for a second. I'm going to say var max equal to 1000. And I want to output max over here. That's perfectly fine. I'm coming here and saying private int, max 1 is equal to 1000. So max 1 var can't do that because it's not a local variable. Now, you could ask the question, why not? I don't see a good reason why not. Because, I mean, it could have done this pretty easily, right? But like I said, they want to take it in dose we can handle. So right now we're getting used to variable. Maybe eventually we can have fields that are type inferred as well. There is really nothing that should stop them from doing it if they really want to. Like I said, other languages actually do this quite happily. There's no reason why this couldn't be permitted. But right now, that's not possible. So you have to specify the type of fields, and that's required. Secondly, not for parameters. Now, I do want to say I am not a fan of type inference for parameters. There are only a few languages that I personally know that does that. Haskell is one of them. F#. These languages can figure out what the type of a parameter is based on the implementation. The reason I'm not happy with it is if I change the implementation, the signature of the method changes. I'm not a big fan of that approach. So when it comes to methods, I want to clearly stabilize the types of the parameters. This is one departure from Haskell when it comes to Scala. Scala has a really healthy dose of type inference, but Scala does not permit type inference for parameters. Scala requires types for parameters, even though Scala was inspired by Haskell, because for the same reason, Scala said, no, we're going to let you decide the type of a method very clearly and stabilize it. We're not going to wing it based on the implementation. Java, I hope, will never provide type inference for parameters. So you have to specify the type for parameters. So if I were to write a method, so public, let's say void foo, int a, and of course you can call the function foo anywhere you want to, but I put a var there, that's not permitted. So you cannot use type inference for parameters. Like I said, I hope this never happens. As much as I'm okay for fields, I'm not really that thrilled about parameter type inference. A few things we have to be very careful about. Well, we talked about where you can use it and where you cannot use it. Just because you can use it doesn't mean you should use it. So you have to make a choice. Don't use it if you are not comfortable with it. Don't use it if your colleagues are not comfortable with it. Don't use it to tease them. Don't use it to make them angry, right? You don't want them to turn postal on you just because you use var in your code. So the point really is, don't use it if you're not comfortable with it. Wait until, developers become really comfortable with it. One day they'll wake up and say, I'm okay, we can use it. And that's a good time to start using var. Until then, just postpone it. You don't need to be pressured to use it. But there are clearly places where you don't want to use it. Let's look at one example here. So what if we tried something like this? So list string names is equal to new array list of string, and this is going to be output, let's say, names. So very simple case. Hey, I'm going to leave the string over here. We know we can do this from Java 7. Well, okay, that worked. Now I'm tempted here to say var. There is a name for this feature. It is called bad idea. So what just happened? What is the type of names? Can you guess?
That's not the real tell.
Well, it knows the type is because the code is compiling, unfortunately. Right? Yeah, exactly, right? So if I were to take this, I can say names.add stir hello. So I can put a hello into this right in here because it's an object. So names.add 1, right? So it's garbage in, garbage out at that point because the type inference said, gosh, I don't know what the type is. You didn't say what the type is here. So I'm going to assume it's a type object, right? And what are the chances you really meant it? I think it's tending towards 0, isn't it? So this is really a bad idea. You don't want to use a var in this particular context. That's not a good idea. What if I had said string over here? Well, if I had said string over here, then you can see that names is a list of string because it knows from the context it's a string. Even this is a bad idea. Why? Because a minute ago, the left side was a type of list. Now, it's a type of array list. Now, again, ask the question, did you mean that really? If you wanted the reference to be a type interface, now it's a type implementation. Maybe that's not what you wanted. So one of the things you have to really ask yourselves is, if I use type inference, is it the same type as I meant it to be? If it is not, then it's not a good candidate to use it. So this is not a good example either, in my opinion, because I want the names to be a list of string, not an array list of string. Why is that a big deal? Well, it depends on how the code behaves with interfaces versus classes. You may not be able to call a method on array list a few minutes ago. Now you are able to call a method on array list. and maybe that's not what you really wanted. So you got to be very careful about it. Again, just because you can use it doesn't mean you should use it, right? So you got to be careful about it. So don't use it with the diamond. Also, not so fast with interfaces. For example, this is not particularly a problem of type inference, but this is more of a side effect from it. So collection of integer, let's say a list is equal to new array list over here of integer. Let's start with this for a minute. And I'm going to say list.add1, list.add2, and list.add3. And I'm going to output the list just to start with. Then I'm going to say list.remove1, and then I'm going to output the list again. So you can see that it contains 2 and 3. So that makes sense, right? Because we removed 1 from it. What if I were to change this to a var? What's going to happen? Well, okay, so it's a type inference. When you run the code this time, is there a difference? You better have unit test, right? So you better have unit test. So notice collection integer, run the code, 2 and 3 is the result. I put a var instead, run the code, it's 1 and 3 instead. This is not a fault of type inference. Type inference is the victim of another poor design, right? So what happened here is, unfortunately, collections remove has a poor overloading in the derived class. So on one hand, it is an index. In the other hand, okay, so he's taking a photo. So give me 1 second. Don't do this. So this is the problem of the world we live in, right? I write a code, people tweet it, and somebody says he's stupid, right? So I'm like, now take the picture you want. Yeah. So that's a terrible thing to do, because on one hand it's an index, in the other hand it's an object that it's removing, and that can be really problematic. So we got to be extremely careful. Just because, again, we can do it doesn't mean we should. We have to be very careful about it. So again, we need to make sure we have enough test. We need to make sure the code is actually doing what it did before, and more important, what we really mean for it to do. The intent has to be really the same still. So these are very tricky areas. We can shoot ourselves in the foot if we're not careful about it. Base versus derived. So that should be kind of obvious. If you use a base class on the left, you can only call the methods of the base class. If you put a var, the type becomes a derived type, which means you can call the derived methods on it, which you couldn't before. So maybe that's not what you really wanted. Cannot be used to store lambdas. Let's talk about what that really means. So let's look at an example. Runnable is equal to, and I'm going to say ucalled. So then what I want to do here is to simply call runnable.run and to say that we are able to call it. Now, what about type inference? So notice var runnable is equal to output ucalled. Will that work? No. Why not? Because look at this for a minute. This lambda doesn't know what the type is, right? Lambdas don't have type until you tie them to an interface. Those are called, of course, functional interfaces. If you don't provide a functional interface, a lambda is kind of unbounded to the type at this point. So the compiler says, hey, look, I don't know enough about this. So compile the code. It's complaining, cannot infer the type of local variable runnable because there's not enough context for me, right? So you cannot use the var to store lambdas. Okay, you know one thing though, when you say you cannot, you often come across developers who say, let me show you how. Very dangerous developers, right? So somebody may come to you and say, I'll show you how to do this. And they will put runnable like that, right? Really, don't. This is terrible because all they proved is they can use var, right? This is totally meaningless. There's zero reason to do this. Because here you're saying there's not enough context, so I'm going to provide context. Well, the place to provide context is here, not over here. So that's why I say, seriously, don't, right? So that's not really worth it at all. Don't go there. But having said that, let's talk about some benefits of really doing type inference. The first one is it reduces clutter. It truly does. When you have a type with 3 or 4 generic types in it, the code begins to smell, isn't it? And all this type information, lengthy information, you have to type it. You may say, you know what? I never type those things. Then what do? I use a beautiful IDE. I right-click on it, and it vomits the code for me. Well, you still have to look at the vomit every day. You got to smell the vomit every day, right? So the reading the code is noisy, not just writing the code. So not useful. It's easy to evolve the code. Honestly, this is one of the things I love the most. Now, ask the question, why do programmers love languages like Python? There is a very simple reason, right? The reason is it doesn't stand in your way. I mean, it's slippery, that's fine, but it doesn't stand in your way. It's a great language to prototype things very quickly. In the case of Java, the more you have to type, it sucks the life out of you from the point of your prototyping, right? Imagine this for a minute. You have a colleague, and colleague is working on something. You say, oh, we can do that in a much easier way. And your colleague is like, really? Can you show it to me how? Sure, step away. And you start typing, and you're typing, and you're typing. And then you're like, no, hang on, I'll make this work. And he's like, I'll come back after lunch, keep working on it, right? So it's like, come on, this is a burden. Why am I typing so many things? Because the compiler says, I want you to give me all that information. Hey, I'm prototyping right now. I don't care about all these details. I want to just get something really quick and working. That can be really powerful to get that going. So it's a really nice way to evolve the code. It's easier to reuse the code as well. So you can assign them to variables very quickly and then pass them around. And it's a lifesaver during debugging. What does that really mean? So I have a function, and I'm passing a parameter to the function. And I want to quickly see what that value really is. So what do you typically do? You store that into a temporary variable. Why are you storing in a temporary variable? Because you just want to take a look at it while you're debugging it. And you're doing it not because you're having fun. You're doing it because the damn code doesn't work. And you want to see this variable. And at that time, the compiler says, let me tell you how things work here. And you're like, please, I just want a glimpse at this variable. Not unless you tell me everything I want you to know, right? This is punishment, isn't it? You just put a var, you see the type, you say, thank you very much, I got this, and you can move on. So it becomes really easy to debug the code. That's one big benefit. 2 other things I want to show you here is that this is something we need to think about. They implemented type inference. Can somebody guess how much time they took to implement type inference? I would have said an hour, right? But no, it is not, because it's very easy for us to. See, this is one of the things I've learned over the years. As a language user, I can say a lot about what the language should do. As a language designer, they have to spend a lot more effort because they got to make sure it works in all situations. So let's look at one example here just to entertain this thought. So I'm going to say list of let's say, string. Well, actually, let's do this. List of object. List is equal to list of 1 comma, let's say, hi. So let's entertain this thought for a minute. And I'm going to print the list over here. So if you look at this one is a list. And let's go ahead and say new array list. And you know what, actually, let's keep it as list of for a second. Now, I want to look at what the type of list is. The type of list is a object, list object, right? So that's very clear to us. Now, what if I had said list.add new sample? Now, just for the sake of record, this is an immutable collection. You'll get an error at runtime. Don't worry about the runtime. Focus on the compiler for a minute. So when I compile the code, no compilation error, as you can see, right? Compiler was happy with it. Why? Because it's a list of object, and you're adding an object to it, no big deal. Now, let's come back to this in a minute. I'm going to take this line of code and I'm going to say over here var. So when I run the code, it is still 1 and high. The question is, what's a type of list? Well, to the human eye, I may say it's a list of object. But this is where the compiler goes an extra mile. And the type is based on what is called an intersection type. So here's a proof of it. If I go here at compile time, try to add an object a sample, I get an error. And the reason I got an error is, notice the type is an intersection type of object, serializable, uncomparable. That's one heck of a type inference, isn't it? So it looked at 1 and string and said, what is common between 1 and string? Well, sure, they both are object. They both are serializable. They both are comparable as well. So the type it inferred based on the context is an intersection type of object serializable and comparable. Sample is not serializable. Sample is not comparable. So I cannot assign sample to it. So the type inference works really hard to distill the type. The reason, yes please.
If you add an int and a double, does it figure out that it's a number?
I don't know. We can find out. So you put a 1 and a 2.2, right? So what does it say here? It still went to the same type. Yeah, it didn't stop at number. Yeah.
No, you edited in the commented line.
What a picky audience. Fine. You are right. Okay. So let's try this one more time. Yeah. So, number. There you go. Awesome. Thank you. So a number, and still it was comparable and not serializable in this case. Yeah. So it was able to infer to the least common denominator. Yeah. So the point really is it works an extra hard to determine the type information based on the context. So we got to be careful. One slight little advantage is an anonymous, non-denotable types. So let's see what that really means. Now this is a little bit of a esoteric case, but nevertheless, it's a case that I really like a lot. Let's take a look at an example. Let's say over here, int get price. Let's take a string ticker, and I'm going to simply return from here. Let's say int just a little let's say a random dot let's say next int. So just a little example of a value that I want to return from here. So that's an integer I'm going to return. Hopefully that'll be an integer value that I'm going to return back from this call. Now what I want to do is a list of, let's say, string, let's call it as stickers, is equal to, let's go ahead and say a list of some tickers, right? So let's take some ticker values. So let's say MSFT, ORCL, just a couple of values. And okay, this is enough. So now what I want to do is walk through these and say tickers.stream and then dot, and I want to say map. Given a ticker, I want to return the price of the ticker, so we can say ticker. And then I'm going to say collect to list and put it into a list. So let's start with this for a minute. So then, what is the type of this? I'm going to say var result is equal to, for now. Then I'm going to say for value in result, and I want to simply print the value out at the very end of this. So all I'm doing is simply going through, looping through, and getting the value and printing it. Okay, hopefully that's not the price. Okay, so now the question here is, what if I wanted to return the ticker and I want to return the price? This is the time I usually complain. I really wish Java had tuples. And Java doesn't have tuple. I'm used to tuples in language like Kotlin and Scala and Haskell and a lot of other languages. We don't have tuples. So what do you normally do in Java to handle this? You create a separate class. That class will have a ticker, and the class will have a price. Okay, that gets a little boring, Wouldn't it be so nice if we don't have to create the type? Okay, to be fair, generally you have to go that route. But what if you're really not interested, you're prototyping, playing with something? Wouldn't it be nice to do something like this? New object. So I'm creating an object right there on the fly, and I say string ticker is equal to, we'll call this as the ticker for a minute. So the ticker is equal to the ticker. And then I'm going to say price, so that's int price is equal to get price on the ticker. So what we did is we created two fields within here. That's all we did. So this is going to be a new object. So we created an object which contains those values. But when you look at it, what is the type of object? The type of object is actually a non-denotable type. The compiler will not give you the type information to code at the compile time. But you can beat the compiler in its own front. You can say, fine, you don't have to tell me what it is. But you can say value.ticker plus, and then you can say value.price. So you're saying you won't tell me what the type is, but you know the type internally. And I will grab it as a var because you just won't allow me to say what the type is, right? It's like the type Voldemort. You don't say its name. You just go with it and say, just give me a property called ticker, give me a property called price. And you can try to get those two values explicitly. So in other words, you are using the type inference to refer to a non-denotable type, and you can just move along. Obviously, you cannot go too far with this. You cannot return this to the caller because you cannot use a var in a return type. So there's a very limited application for this, but it's something you can actually leverage if you really wanted to. And one last thing I want to quickly mention here is that var is not a keyword. If you really, really hate everybody that you work with, you can do this at work, is equal to 7. And then you can write the code like this, right? And drive everyone crazy. So go for it. So, and they will just love you after that, right? So, and that's the beauty. Var is not a keyword. So because it's not a keyword, you can use var. It knows what the context is based on what you're trying to do. So you can do that very nicely. So to summarize a few things, one of the other things in Java 11 they introduced is that var can be used on lambdas. At the first thought I thought about is that's really stupid. Why would you want to do it? But there's a really good reason for it. Let's look at an example of this. So if I said integer right here, and in this case, if I say list is equal to, let's say list of, let's create a bunch of numbers here, list of numbers 1 to 10. So what I want to do here is use a lambda, so I could say list dot for each. Remember, I can simply say use type inference like this. But remember the limitation in Java 8. You cannot put final in front of this, right? Similarly, you cannot put annotations in front of it. So for example, if you really wanted to say not null, for example, you couldn't do this. Well, what if I don't care about the type, but I want to use the annotation? That's when you can put a var. So the var simply allows you to skip the type information and yet for you to use the various annotations, if you will, and you can permit that. So as you can see, this will not work in Java 8, but in Java 11, this actually works. And the reason why they introduced this was so you could perform annotations. So you can put things like final or at not null or other annotations, and yet you can skip the type information. That's one really nice thing that you have in Java 11. So you cannot mix the var with type information. So if you have multiple parameters, you cannot put a var for one and type for another. Everything is a var or everything is fully typed. And you cannot mix var with implicit type also. So you have to really use one or the other. And of course, is it really useful? It's very useful, and that is for using annotations. So bunch of recommendations. Couple of things to remember. Don't use var with diamond. We saw this earlier. When you use diamond, the inference becomes object. That's terrible. Don't do it. Second, don't put type in the name. So here's something I've noticed people doing, and I want to emphasize this. So don't do this. Don't say list string names is equal to list of let's say, for example, over here, let's say Sarah, right? So you are taking this one and you want to use a var. So what I've noticed people do is var names list. They just can't let go, right? So this is a sign of people clinging on to type information. Call it names, not names list right now. So don't append type information to variable names and put a var. It kind of defeats the purpose. So names, not names list, not list of names, just names. So don't put type information with it. Make sure that the type is what you really wanted it to be, not some other type. We saw examples of that also. Specify type unless it is really, really obvious. If you look at it and say, hey, I'm not sure what the type is, then don't bother using var. Just be happy saying the type. Use var for temp, use it for debugging purposes. So normally where I use a var is temporary variables. This is one of the reasons why it's nice for local variables, right? In a very small scope, you just put a var, the context makes this very clear, don't take it too far. You can use this for reusing across variables across. What I mean by this is, suppose you're passing a fairly complex argument to a function, you can quickly assign it to a variable, and then you can reuse it in multiple places. This is especially true when it comes to things like comparing and reverse and all that. You can store them into a variable. You can also use it for annotating the lambda parameters as well. That's basically where it's very useful. So to summarize what we talked about, we've been having type inference for a long time in Java, from Java 5, a little bit more in Java 8, a little bit more in each release of Java. But Java 10 gives us the local variable. I truly believe it's a friend, but at the same time, it can be misused as well. So use it where it's very obvious. Use it where it becomes a benefit. Don't use it where it's confusing, and definitely don't use it where it's going to give you a bad result. So there is equal number of good uses and bad uses we saw here, I think, and we got to make the choice and be careful where we use it. Nothing to fear. I think it's something very valuable. I really enjoy using it. Like I said, I use type inference quite heavily when I program in language like Scala and Kotlin. When it comes to Java, I'm happy that we have this capability, but we got to use it carefully as well. As in those languages, the problems in those languages exist too. It's just that we don't complain about it too much in those languages because it's natural in those languages. We have had it from the day one. Whereas now it's being introduced in Java, we are going through that transition more than anything else. Questions or comments before we wrap this up? Yes, please.
So you mentioned that it is, compiler has to find out the context and it has to make reference. So is there any impact in terms of performance?
No, not at all. So the question is there an impact on performance? The answer is no. Yeah, the compiler has to work a little extra to do this, but it has zero impact on runtime. So it's as good as you having written the type at compile time. So no impact on performance at all. Runtime performance, that is, not at all. Yeah. Any other questions? Please.
For the intersection types, are we basically just walking up the type tree in a sense?
I'm sure it's a lot more complex internally for them to implement it. They got to do extensive analysis to find it because they have to make sure that it's compatible also in terms of where it's being used. They have to analyze. So imagine you are taking an existing code and you're converting it to using a var. They cannot lightly just use a hierarchy and determine it. They go through a complex process to determine it. That's all we have. Thank you.
All right, big round of applause.
Thank you. Thank you.